an extraordinary display by a flock of starlings, a so-called murmuration, a pulsating, palpitating example of swarm or group behavior. It's something we see in lots of species, fish, bees, ants, each individual, both one and the many, at the same time. Scientists have long been fascinated by it and are convinced we can learn from it for our own devices. Dr. Sabine Howard is a Swiss-American scientist. She describes herself as a swarm engineer. Her aim to imitate nature.
If you look at birds and ants, they can do these beautiful complex behaviors, and I take inspiration from these to engineer solutions for real-world applications. So we're designing swarms of robots that could be used for outdoor applications and nanoparticles that work in the trillions for cancer research.
An arena in a robotics lab in Bristol in the west of England. Howard's research group are rallying their army of so-called kilobots. Arranged at one end, a phalanx of them, ready for the order to move.
The thing I liked about this is instantly I recognized the sound of the swarm.
It definitely sounds like a swarm. It really buzzes.
So what's the purpose of all this?
Robots are a wonderful way to visualize swarm dynamics, and so we use these as a proxy for the nanoparticles. Our nanoparticle robots are released from a vessel here on the side of the arena, and then they move randomly, and they can go and they can stick to cancer cells, which we've projected on this arena. And once they've been eaten up by the cell, they turn blue. And so we use this to show that although these particles are great at accumulating within these cancer cells, they're poor at penetrating deep into this robotic tissue. So the group behavior is not great, even though the individual behavior is actually quite smart.
Have you learned much from this already?
I've learned tremendously just programming them and seeing how they behave.
Back in the arena, the kilobots form up again, ready to showcase their other swarm behaviors. The army is preparing to show its colours. The bots demonstrate decision-making by changing from red to blue as a group, replicating how swarms might choose a nesting site. This time it's all about synchronization, mimicking how fireflies can coordinate their glow. And here, like ants, creating a trail from a so-called source, transferring information back to their nest, the bot stopping once the link has been made. And Howard is hoping her research can find uses in the outside world, a human-engineered robotic swarm to rival those created by nature.
I'd love to see these swarms of robots do things like monitor water sources, do things like explore a building that's collapsed, do things like potentially clean up an oil spill. We can't engineer systems like this yet, so I think why not look at nature for some of these solutions?